Hi folks, Mr. Long here. We're going to do some cross-product work, and I know that you understand the concept of cross-product really well. Now we need to develop some fluency, procedure-wise. What we have is vector A is listed there, vector B is listed there. And then what we're going to do is cross-product the two vectors. And the way we're going to do that is to stack them vertically. And we're going to add an extra column here of X again. And as we go through this, I think you understand conceptually why you work with Y and Z components to generate the X component of our new vector, our new cross-product vector. And we do it with crosses. That's why they call it the cross product. And what we're doing is we're going to multiply -3 and 2 and then subtract off 1 and -9 to get our X component. Okay, so let's go ahead and do that. So it's going to be -3 times by 2 minus 9 times 1, and that will give us our X component of our new vector. And then I go to do my, to get the, I need to repeat the X component here, 3 and 4. So now what I need to do is I'm going to multiply Z and X together, right here and here to generate the Y component. So Z and X. So I'm going to have 1 times 4 minus 2 times 3. So 1 and 4 minus 2 times 3, and that's going to give us a certain value as well, and that's going to give us our Y component. And then finally I need to figure out the Z component. And again, I'm going to do a cross product. And the cross product of that, there's Z right there, so I'm going to do X times Y minus the Y components, right? So X, Y here, and then XY again in a cross product form. So when we do that, we will end up with 3 times by 9 minus 4 times -3. Okay, so we multiply the X and the Y to get Z, and then we need to simplify that. So to simplify that, we're going to get, and I'll write it here, our -3 times 2 minus 9 times 1 is going to work out to -15, comma, and then 1 times 4 is 4, minus 6 is going to be -2, comma, and then last one is going to be 3 times 9, 27, minus a -12 is going to be 39. Okay, and that's your cross product of vectors. So again, the key there is to add that extra column and then to do your cross products. So start off with crossing Y and Z, and then cross to get your X component, then cross Z and X to get your Y component, and finally cross X and Y to get your Z component. I hope I said that right. Anyway, procedurally, that's the way to do it. So next, let's go and actually look at the formula. So let's do this just with the formula, right? So we can do this now. This will be AX, and this would be BX. So again, to get the X components, I am going to do Y and Z. So I'm going to have AY times BZ minus BY AZ. Next, I'm doing ZX. I'm doing X, Z and X to get the Y component. So it's going to be AZ multiplied by BX minus BZ multiplied by AX. And finally, I figure out the Z component, which is going to be crossing the X and the Y, and that will be AX BY minus BX and AY. Okay, and that's your formula for the cross product when you're crossing two vectors, A and B. Okay, last thing I want to do, quick one, and I would like to do the parallelogram area. The first part of our lesson we developed the geometric form, which is really like the scalar form of the cross product, where you just get magnitude, and it was a times b times sine theta. And this is interesting because it gives us an opportunity to get the area of a parallelogram. So what we know is, sorry, just dropped my coffee cup. What we know is the area of a parallelogram is base multiplied by height. So in this case, the base is actually vector b, right? That's your b. And then we've got height right here. There's our height. So I've got the base right here, folks, and the height right here. But now what I need to do is get that height in terms of vector A. So if you notice, h is opposite angle theta. So opposite, that's sine. So h is going to be A multiplied by sine of theta. So what we'll do is we'll put it in the same formula. The base is vector b, magnitude, and then that height is equal to the magnitude of a vector multiplied by sine of theta. Okay, so the area is b vector, a vector, sine theta. So the area of any shape is the cross product, right? A cross b magnitude. Okay, because you know this, b, a, sine theta. That's the formula for the cross product. So anytime you want to get the area of a parallelogram, you do the cross product and get the magnitude. Now the other interesting thing that we'll look at very, very quickly is that the area of a triangle then is going to be half of the area of a parallelogram. So if you want to get the area of this triangle right here, you would get the area of the associated parallelogram and divide by 2. Okay, so what I would suggest to you now is you go over the video again to see the calculations, development of the formula, etc., and hopefully that helps. Have a great day.